So in today's video we're going to be looking at the laws of logarithms. So there really is only a few that you need to know. I'm just going to quickly give them to you before we just dive into some examples. We're going to look first at the product law, which basically states that if you have a log with a base a and you have x times y, that is the same as saying log base a x plus log base a y. So this is an identity. Similarly, we also have a quotient law. So if you have a log of the base a and you have x over y, that is also the same as saying log base a x minus log base a y. And the final one is going to be our power law, which basically states if you have a log base a with x to the power of r, that is the same as saying r log a to the power of x, which basically means you brought down the r. So I would highly advise that everybody, wrap their heads around this. It's a really good thing to, keep in mind. So let's see if we can actually do some examples with these. Let's say we have log base 3 6 plus log base 3 4.5, and I tell you, go ahead, evaluate this, give me what it is. We know that from our product law that log a xy is equal to log a x plus log a y, and we have that here and here, so we can easily just put it into this form. So let's go ahead and do that because we have the same base. So we have log 3 6 times 4.5, and that is equal to log 3. 6 times 4.5 should be 27. And we know what the answer to that is. If log 3 27 is equal to x, then 3 to the power of x is equal to 27. And we know that x has to be 3, because that's what gives us, so x is equal to 3. And see how easy math just became. So let's do another one. This time let's do a subtraction. And you already know I'm going to tell you that log a x minus log a y let's do our dividing, because we're so efficient with math. Now that we can quickly do this on the fly. Which means I have log base 2 times 16. And I know that 2 to the x should give me 16, so I guess that's 2 times 2 is 4, times 2 is 8, times 2 is 16, so x equals 4. I should have been able to do that quicker in my head. Let's do log base 5, 3 to the, base 5, cube root 3, 25. So, if you remember you can see the pattern where I'm going with this one. If you have log base a, x to the r, you can write that as r log a to the power, to the value of x. You might be wondering, what's our r? Well, actually, this we can rewrite as log 5, 25 to the 1 over 3. So, let's rewrite that over here, 1 over 3, log 5, 25. Now this expression here, log 5, 25, that should give me, that alone should give me 5 to the x equals 25, so x equals 2, so 1 over 3 times 2, 2 over 3, and really that's honestly how easy math is. I would not stress too much about it. So far, we've only done easy things. Let's actually do something a little more messed up. Let's do this. Let's say I have this log a x cubed y squared over w. And now I want to represent this in terms of log ax, log ay, and log aw. So, let's start doing this. I want to basically disassemble this entire thing and rewrite it in terms of 1, 2, and 3. So, the first thing I'm going to do is take this exponent here, log a, and then x cubed y squared over w to the power of 1 over 2. And now that I have that, I can move that down using our product law, which is this, like open the bracket up. So I can write 1 over 2 for this one. This one would just be 1 because it'd be 2 over 2. So I can write like that. And our first one would become 3 over 2. And there we have our end result from this all the way to this. And we can actually even work backwards to come up with the solution. So that is all the examples I'm going to go through this one. I'll leave you with a parting gift. Maybe, let's see. Evaluate that one. Maybe even you can do let's see. So that's 1, that's 2. That's log base 2 of 224 and minus log base 2 of 7. So that's all for this video, and I shall see